Hi everyone, this is Ethan Chen. Today I'm going to talk about regression applied to baseball statistics. Statistics have been used in baseball since its inception. The dataset we will use, which is included in the Herman library, dates back to the 19th century. For example, a statistical summary that we will describe soon. The batting average has been used for decades to summarize a hitter's success. Other statistics, such as home runs, RBIs, or runs batted in, and stolen bases, are indicated for each player's player in the game. Summaries included in the section of newspaper sports, with players rewarded by high numbers. Although statistical summaries like a list were widely used in baseball, the data analysis itself was ignored. These statistics were chosen without without much thought about whether they are actually predict something or were related to helping a team with. This changed with Bill James in the late 1970s. This baseball fan and a spring winter writer began publishing articles and that described a deeper analysis of baseball data. He called sabermetric, and the approach of using data to predict which outcomes best predict whether a team will win. Until Billy Beane made the sabermetrics the center of his baseball operation, the baseball world generally ignored the work of Bill James. Today, the popularity of sabermetrics is no longer just limited to baseball. Several other sports also started to use this approach. And here we will focus on runs scored and ignore the other two important aspects of the game, pitching and fielding. We will see how regression analysis can help develop strategies to build a competitive baseball team on a limited budget. And no price for BB. And historically, batting average has been considered the most important offensive statistic. To define this average, we define a hit and at a bat, singles, doubles, triples, and home runs are hits. The fifth way to be successful, BB, is not a success. AB is the number of the times a batter has a hit or out. BBs are excluded. The batting average is simply H or AB, and is considered the main measure of a success rate. Today, this success rate ranges from 20% to 38%. We mean batting average in thousands. So, for example, if your success rate is 28%, we say you are hitting 280. Bill James' first big idea is that batting average ignores BB, but BB is a hit. James proposed using the on-base percentage, or percentage of times a batter reaches the base instead of the batting average. He defined BP as H plus BB over AB plus BB. Which is simply the proportion of the bats that do not result in an out. A very intuitive measures. He noted that a player who gets no more BB than the average player might not be recognized if his bat average is not high, but isn't this the player helping produce runs? Still, no prize is awarded to player which the most BB. Also, baseball did not immediately adopt the OBP as an important statistic. In contrast, the total stolen base is considered significant, and the player with the most is awarded a prize. But players with a high BB totals also make more outs, as they are not always successful. Does a player with a high SB total help to produce runs? Can we use data science to determine if it is better to pay for players with high BB and SB stolen? Let's start with obvious one. I try to the teams and with the most home runs scored, the most runs. We examined the data from 1961 to 2001. The visualization of options by exploring the relation between two variables such as HR and trumps on a scalpel.
All right, and thanks to what I learned from the R and the R Studio course, the website gonna be datacam dot www.datacam.com. All right.
Alright, we do some calculation, and here's the graph that shows the relation between HR per game and R per game. The next step, we do the same calculation. You see that, and it shows the graph between SP per game and runs per game. In the next step, we also need to do some calculation and shows the graph between the BB per game and run per game. The next one is the HR per game and the BB per game. And next one is the regression applied to baseball statistics. Now we are ready to use the linear regression to predict the number of runs a team will score if we know how many home runs the team will hit. All we need to do is do the calculation, calculate the 5 statistical summaries, and see the steps. Now we can create the regression lines. And in this graph, it shows kind of positive, strong relationship between the HR per game and the R runs per game. The slope is 1.845. This tells us that teams that get 1 HR more per game than the average team score more runs per game than average team. Since the most common final scores is the difference of a race, this can certainly lead to a large increase in wins. Not surprisingly, players with a lot of HRs are very expensive. Because we are working on a tight budget, we will need to find another way to increase wins, so we turn our attention to BB. And same thing, we do some calculation, get a slope, so we're gonna be 0.735. And so this means that if we hire low-paying players with lots of BBs, and thus increase the number of BBs per game by 2, our team will score 1.5 more runs per game. Again, we must remember that association does not imply causality. The data provides strong evidence that a team with 2 more BBs per game than the average team scores 1.5 runs per game. But this does not mean that BBs have the causes. Notice that if we calculate the slope of the regression line for singles, we get see that we got slope as 0.449, and which is the lower value than the one we get from BB. And understanding this through satisfaction of the first approach is to keep HRR fixed at a certain value and then examine the relationship between BBs and runs. Here we can stratify HRR by game to the nearest 10. We filter the strata with few points to avoid highly variable estimates and see the calculation, and we can make a scatter plot for each student and see the 9 graphs is like different 0.4, 0.5, 0.6 to 1.2. Remember that the regression slope is for predicting runs with BB was 0.7, and once we stratified by HR, these slope are substantially reduced, and see the different answer solutions for 0.4 to 1.2. And the conclusion on the slope are reduced but not zero, indicating that BBs are useful for producing runs, but not as much as previously thought. In fact, the above values are closer to the slope we got from singles, 0.45, which is more consistent with our intuition. Since both singers and BBs get asked to first base, they should have roughly the same predictive power.
All right, that's it. Thank you. All right.